Suramani. We were discussing about the plants and equipments in our earlier discussions. We discussed about the importance of the plants and equipments. As discussed, the cost component in highway project with respect to plants and equipment is about 15 to 20%, and the advantages of plants and machinery we had discussed. Some of the limitations also we have discussed, and then we passed on our discussions to the crushers, and we discussed the crushing process, different types of crushing process, different types of crushers based on mobility, based on function. And then we discussed the jaw crusher, the primary, generally the primary crusher used for crushing operation. And now let us start our discussion on impact crushers, which is used for second stage crushing generally. Now this is the diagram you can see here of an impact crusher. There is a rotor attached with hammer plates, and then we have repulsion plates also, and this is the inlet. Through the conveyor belt, the crushed materials are fed into this impact crusher, and this is where the outlet is. The crushed material goes out from here either to the stockpiles or to the uh, tertiary crushing plant. This is another view of the impact crushing plant, and let's see how these impact crushers work. Basically, here the aggregates are crushed or broken by impact. In jaw crusher, it is the compressive force which is used for crushing of the material. Here it is by impact. These impact crushers are also used for sometimes primary crushing also. When the material is too hard, these impact crushers are used. We get very good output uh, from the impact crushers. We get well graded cubical shape aggregates, and how this breaking happens, as I said, or as we can see in the figure, uh, the we can see the hammers and repulsion plates. When stones or the aggregates, crushed material is fed into the impact crusher from the top, they are struck by the rotating hammers in the braking chamber, and these hammers repeatedly throw the materials against the breaker bars. Since the impact is instantaneous, braking eliminates the possibility of development of hidden cracks in the material. That's where we get very good materials. How did we get our, how do we get this impact, instantaneous impact in the impact crusher? Number one, the rotating impact hammers striking the material. That's where we get the impact. The other impact we get is from particle hitting each other. The second one. Third impact we get materials striking against the breaker plates. This impact crusher gives high reduction ratio. That means the size of the input, the size of the output will differ largely. That means we get high reduction ratio. The effective production of high percentage of fines whenever for any project, or when we want more finer content, we can use this impact crushers because it generates more percentage of fines. And as I said, we also get good shape, good cubical shape, better strength, because there will not be any hidden cracks, and output is also quite high. Now let's go to the cone crusher. This cone crusher is also either used as a secondary stage crusher or for tertiary stage crushing. This is how a typical cone crusher looks. This is the cone. This is the cone. This is another diagram of the cone crusher. Most of the times, or generally, cone crushers are used to produce final product. The input is also smaller size, or the crusher material what we feed for the cone crusher generally of construction size or smaller size, and we get more fine aggregates. The crushing surface the between or the clearance between concave and the mantle is the crushing surface or crushing area. The crusher head has a gyratory and swinging motion. This swinging motion is produced by eccentric sleeve rotation. Sleeve rotation. Now let us see what are the factors that influences the crusher output. This output depends on several factors: jaw opening, the size of opening of the jaw in the primary crusher influences the output. Lesser the opening, lesser is the output. And then second, end product. If we want the output of consisting of larger size, then definitely generally we get more output. If we want the output of smaller sizes, naturally the output reduces. So it depends on what is the end product that we desire, otherwise the size. The third, nature of the material, rocks. If the rock is soft and then less quantity of dust, the output will be more. The fourth one is the feeding efficiency. How are we feeding the crusher? Is the feeding is continuous, or is feeding is full, optimum? It depends on that. Generally, if the feeding is continuous, the feeding is full, we get more output. Otherwise, it will be less. The output also depends on the bulk density. More is the bulk density, output, more is the output. The output also depends upon the water absorption. If the lesser is the water content, output will be more. It also depends on specific gravity. The output of the crusher output depends on the inversely proportional to the output. More is the specific gravity, lesser is the output, or lesser is the specific gravity of the feed, more is the output. Finally, the crusher output also depends on the size of aggregate of the raw material. Smaller the size of the feed, more is the output. That's about the crushers.